let's do a quick review about the concept of reference states. And so, back in chapter 7, we talked about how we can't really know the absolute value of enthalpy or internal energy. Right? We can't directly measure them. So, cannot directly measure U and H. But really, for our purposes, that doesn't matter too much, because in our energy balance, we're only looking at the differences between the internal energies, or the differences between the enthalpies. And so since we only care about the differences here, what we do in case we need to calculate, a internal energy at a specific temperature or so, is we calculate that value in reference to a reference state, or relative to a reference state. So we define a reference state. And when I say reference state, it's specifically a chemical species at some phase, some temperature, and some pressure. And we use those conditions to have a starting point for our comparison. Starting point for comparing. How a chemical species changes throughout a process. Okay? And I want to make sure that, we're consistent here. So we could say that if we have a specific internal energy, we could say if it's our reference, it's going to be equal to 0. Right? We could define either internal energy or the enthalpy, reference enthalpy, to have a value of 0. But when we choose one to be equal to 0, by definition, the other one cannot be 0. So if we say that the internal energy, reference internal energy, is 0, that means that our reference enthalpy cannot be 0. Okay? And that just goes back to the relationship between enthalpy and internal energy. So enthalpy, right, is internal energy plus pressure and volume, specific volume, right? And so in this case, if we said that U ref was equal to 0, that means that our enthalpy is going to be equal to the pressure times the specific volume, reference one, right? And for actual physical values, those can't be equal to 0. They can be very close to 0, they can be very small, but rigorously, it won't be exactly equal to 0, like we're saying this is. But that's just a minor point. All right. In any case, for common chemical species that we encounter, perhaps the most common one is water. Typically, our reference internal energy, our reference state for water, is going to be the triple point, specifically liquid water at the triple point. So for the reference phase, we say liquid. For the temperature, at the triple point, it's 0.01 degrees Celsius, and the pressure is 0.00611 bar. Right? So at that triple point for the liquid, we say that's equal to 0. So vicariously, if we calculate the reference enthalpy, this will be 0. But the pressure and the specific volume are not 0. They have actual values. Specifically, the pressure is this, right? And the density or the specific volume has a value. And so if we plug that in, our reference enthalpy is actually going to be 6.1 times 10 to the negative 4 kilojoules per kilogram, which is greater than 0.